Welcome to another Earth Science podcast. I'm your host, Mr. Buss, and this podcast is going to focus on plate tectonic theory. First thing I want to do is clarify a few terms here. Continental drift hypothesis. Now remember, that's Alfred Wegener. Early 1900s, he came up with the idea that the land masses and continents are moving. Remember, his idea wasn't accepted at the time because it lacked a mechanism. Another concept is seafloor spreading. After World War II, we obtained a tremendous amount of data and information about what the ocean features looked like. We talked about mid-ocean ridges, abyssal plains, and trenches. And so with seafloor spreading, we have the mechanism that Wegener didn't have, and we have this idea that at these mid-ocean ridges, the crust is formed, and it is pushing the continents and the seafloor away from the ridge. And third, we have plate tectonic theory, and what that really does is it takes continental drift hypothesis and adds it to seafloor spreading. And so the end result of plate tectonic theory is basically Alfred Wegener's continental drift hypothesis. Plate tectonic theory does state that the plates are moving. The continents did used to be together as Pangea and so on. But then the mechanism is seafloor spreading. It occurs because of the spreading that is occurring at the mid-ocean ridges. And plate tectonic theory then goes ahead and says these are all the Earth's plates moving along on this Earth's surface that is in no way stationary. And over billions of years, millions of years, it's very fluid and dynamic and constantly changing. I'll just mention the word theory here. Remember, theory in science is a huge idea. It doesn't really get any bigger than theory. Theory is different than law. Laws and theories don't go from theories to laws or laws to theories. We have plate tectonic theory, theory of gravity, evolutionary theory. And in science, a theory is not a guess. It is a concept or idea that not only explains the past, but predicts the future as well with our understanding of the Earth. And so let's understand plate tectonic theory a little further. As has been mentioned, Alfred Wegener's missing mechanism is the seafloor spreading, and let's get into how that actually happens and why it happens the way it does. Before we get any further, you need to understand this term of convection. Convection is defined as the circulatory motion that occurs in a fluid at a non-uniform temperature. That's confusing. I got that from the Merriam-Webster dictionary. Think of it in simple terms. Think of a lava lamp. In a lava lamp, you have a heat source, such as a light bulb, at the base of this thing, kind of shining off light and also giving off heat. And so the oil in the lamp heats from the bottom and will rise. And as the oil gets to the top, it cools off and returns back to the bottom, or the base of the lava lamp. So the lava lamp basically has oil that's going through convection. It's heating from the bottom and cooling at the top and just keeps going back and forth. So think of the Earth as one giant lava lamp. You've got the mid-ocean ridge kind of seen right here on the Earth. And that the light bulb in the lava lamp is really the core of the Earth. Okay? And it's giving off heat, well, because of the radioactive materials in the core, the gravity, all sorts of reasons for the heat in the core, but there's heat in the core. And that heat causes the mantle to heat up, and the mantle, which is liquid type of rock, is rising, and as it reaches the surface, it cools, and then heads back down, and basically you've got a lava lamp. What does that have to do with seafloor spreading? Well, it's this motion of mantle rock moving up and then scraping across the crust, and that rips in half. It rips open the Earth at the ridge, and that is the place where some of that magma will cool, and so new Earth is being formed at the ridges, and this scraping across is pulling the continents along with it. Here's kind of a textbook image of what I'm talking about. Again, you've got these convection currents sweeping up from the core, gliding and scraping along the crust, bringing the crust with it, and ripping open the Earth at the trenches where new Earth is formed. So there's the mechanism. And again, we can't see this happening, right? So this that's a big reason why we call it, a theory. We can use this, we can predict with it, but certainly this is something that, humans are coming up with and saying this is probably what's happening, and we're very, very confident with this mechanism and this theory. I guess we can kind of see it because we can see the mid-ocean ridge forming rock and all that stuff, so we do see it. So now let's take a look at three very different places on the Earth where this is occurring: the African Rift Valley, the Red Sea, and the Atlantic Ocean. So all three of these places, the African Rift Valley, the Red Sea, and the Atlantic Ocean, are places where the Earth is ripping apart. The crust is ripping apart. It's where new crust is being formed. It's just that these three are all, they have not been ripping for as long. The African Rift Valley is going to look more similar to these first two images, whereas the Red Sea is a little further along, and the Atlantic Ocean is basically all the way, and is a very old rift. So let's take a look at the Africa Rift Valley first. It's the newest type of, formation where basically the Earth is ripping in half. You don't even have ocean there yet, but you can definitely see the rift, the breaking in half. If you look at an actual picture of it, basically, you're just looking at these areas of rift here where the Earth is splitting here, the Gulf Sea, Gulf of Aden, and then also right along here in Africa, just new land getting ripped in half. Now, Africa is not the only place this is happening. Iceland is actually getting ripped in half as well. This is the beginnings of a new ocean. Eventually, it's going to take a lot more than just a little bridge to get from one side of this to the other. Right now, it's just sand and dirt and debris. But at the rate your fingernails grow, basically about a centimeter a year, this is moving further and further apart. And eventually, we're going to be gone. But eventually, this is going to be a very vast and deep ocean separating the two sides of Iceland here. So those are examples of new rift. And so the Red Sea has been rifting for longer than Iceland or Africa down here. So the Red Sea is filled in with water, with ocean, or the beginnings of an ocean, a sea. So there's Africa, a lot of geologic activity there with rifting. And so here's the end result. What happens when the rift has been going on for a very long time? Well, there's the Atlantic Ocean rift. So just kind of compare and contrast the different types of rifting that you can find on the face of the Earth. Well, I've spent a long time on this podcast, but I feel like it was important to really understand, really a lot for why the Earth looks the way it does. If you can understand plate tectonics, I think you can really get a handle for just about every feature, geologic feature that we find on the planet today. And that concludes this podcast on how continental drift hypothesis and seafloor spreading equal plate tectonic theory.